Hello pre-calculus kids. Today I want to give you some extra examples from the practice problems from section 11.2 on negative and Pythagorean identities. And so I'm going to just pick and choose some of the ones that I think might be a little more challenging. The first one is not that challenging, but some of the others are. This one you might wonder like what you're supposed to do with this, and it might kind of remind you of the Pythagorean identities, but there's not a square there, right? You can only use the Pythagorean identities when there's a square involved. So I'm looking at these two things and I'm like, everybody's in terms of sine and cosine, right? So I don't have any changes that I really can screamingly want to make on this thing. But I do look at it and I'm like, well, this is 1 minus cosine, this is a 1 plus cosine. Let me try foiling them together. So if I were to FOIL them, I would get 1 times 1 is 1. 1 plus times a positive cosine is plus a cosine. Negative cosine times 1 is a negative cosine. And negative cosine times positive cosine is a negative cosine squared. Now again, these are simplified, these aren't verified. So if I look at that, I can see my cosines cancel each other out, and here's what I'm left with. Oh, by the way, it's all over cosine squared, right? So my numerator becomes a 1 minus cosine squared, because these guys cancel out. And then I have, on the bottom, a cosine squared. Now, some of you might want to just cancel the cosine squareds. Oh, cool, I got one up top, I got one down the bottom. That's awesome. Let me cancel them out. And the deal is you can't do that because there's a minus side involved. If they were just multiplied or if the 1 wasn't there, then absolutely cancel away. But this one doesn't work because you've got a subtraction sign there. So if you go to your identities, 1 minus cosine squared is actually the sine squared x. And sine over cosine is tangent. Because they're squared, tangent will be squared as well. And that's your answer for number 3. All right, next one on this page that I want to go to because it gets a little dicey is number 6. Give yourself some room for Mr. Number 6 because there's not any identities screaming at me on this one either. So what I need to do is change everybody to be in terms of sines and cosines. And that's what I want to do with this. All right, so watch. This gets really kind of crazy. I have a 1 plus, that's not crazy, 1 plus, tangent of, I don't even know what this symbol is, but I'm going to make it be like a y. So sine over cosine is tangent, sine of y over cosine of y. That's my numerator, right? That's 1 plus tangent. The denominator is 1 plus cotangent, and I'm actually going to go horizontal and change it into a division problem so I don't get those crazy complex fractions. If I have 1 plus cotangent, that's 1 plus cosine over sine. This is a verifying. It's supposed to equal a tangent, which is sine over cosine. All right, that's my goal. If I take one set of parentheses at a time and I get a common denominator, this is 1 over 1, common denominator would be cosine. This one needs it. I'm going to multiply by cosine. Gives me cosine times 1 is cosine. This one already has it, so I don't have to do anything. It's just going to be plus the sine of y. So my first set of parentheses looks like this. Second set of parentheses, I'm going to do exactly the same thing. I'm going to get a common denominator. In this case, it's a sine. This one needs it, so I multiply by sine over sine. Sine times 1 is sine. This one has it, so I don't have to do anything to it. Cosine of y. And supposedly, when I'm done, it'll be the sine of y over the cosine of y. Y, not x. Okay, so if I'm dividing by a fraction, I have to multiply by the reciprocal, so that's going to give me this. Cosine of y plus the sine of y over the cosine of y, that's this guy, times, keep change flip, I am flipping, gives me sine of y over sine of y plus cosine of y, and supposedly it equals the sine of y over the cosine of y. Let's see if it does. I have a cosine of y plus sine, I have a sine plus cosine. They are exactly the same thing. I just have flipped their order, changed their order, but they're exactly the same piece. So this cancels with this, and look at what you're left with. You are left with the sine of y over the cosine of y on the left, and the sine of y over the cosine of y on the right, and you have just verified that identity. Takes us to number 7, the next one that I think is really challenging. This one, everybody's in sines and cosines except for this over here. So this one is going to be like, we can leave it as 2 secant or make it 2 over the cosine, but we'll do that in a few minutes. I'm trying to add 2 fractions. I need a common denominator, but guess what this common denominator is? It's a hot mess. It is one of each thing. 1 plus the sine of x and 1 minus the sine of x. Okay, so this one has the 1 plus sign, it needs the 1 minus sign. So over here I got to multiply him by 1 minus the sine over 1 minus the sine, which makes me multiply cosine times 1 is cosine, and cosine times sine is negative cosine sine. I distribute the cosine. Cosine times 1, cosine times sine gives me this. Then I come to a plus sign. Let me extend that, right? I have to do the same thing over here. This guy has the 1 minus sign. It needs the 1 plus sign. And so I'm going to do the same thing. I'm going to distribute the cosine numerator with this. Cosine times 1 is cosine. It's positive. Cosine of x. Cosine times sine is positive cosine sine. And this is supposed to equal 2 secant. Secant is 1 over cosine, so 2 over cosine. Let's see if there's any goodness that comes out of this whole thing. I have a negative cosine sine. I have a positive cosine sine. They're gone. That gives me a cosine plus another cosine. I have 2 cosines. I'm adding 2 cosines on top. Again, this is supposed to equal 2 over the cosine of x. Let's talk this denominator. 1 plus sine, 1 minus sine. If I were to multiply them together, it kind of reminds me back to number 3. Remember this guy? Number 3 that we just did a minute ago? It's the same idea. If I were to FOIL them together, 1 plus the, or 1 minus the sine times 1 plus the sine is going to FOIL out this same exact way, where my middle terms, my outers and inners, are going to cancel each other out. So let's see how that works for number 7. 1 times 1 is 1. I have a minus sign. I have a plus sign. They're going to cancel each other out. You can write it and cancel them, or just remember that that happens. And a positive times a negative is a negative, so it's a negative sine squared x. Well, I'm not quite there yet, right? I still have something else I need to do. So I go to my Pythagorean identities and I realize that 1 minus the sine squared is actually cosine squared. So on the left I have 2 over, 2 cosine of x over cosine squared x is supposed to equal this. And I'm right there because I have 2 cosines on the bottom. I have 1 on the top. They cancel 1 for 1. And I'm left with 2 over the cosine of x equals 2 over the cosine of x. That's number 7. A couple more to go. On the next page, only number 11 was on my radar as being something crazy that you hadn't seen anything like it quite before. Also, the symbol in number 10 is kind of weird. You can call it an X or call the angle whatever you want. I'm not even sure what letter that is, but anyway, it's like an upside down Y. So if you want to change that to an X, that's fine. This is the one though that I want to look at, because this one, again, I need a common denominator. There's no Pythagorean identities that I can do with this. There's absolutely, I could go signing and cosigning, but that's going to get, which was actually where we're going to go eventually. Or maybe not. Maybe there would be an easier way. By the way, there's lots of different ways you can approach these, and any one could be correct. Just because I'm taking you on one road doesn't mean it's the only road, but in the end, you should get the same verifying answer for your problem. So you may take a different road, and you may be perfectly correct, and that's okay. So lots of different avenues with these, which makes them kind of hard, because there's not just one distinct way to do the problems. All right, let's go with thinking about common denominators for this next one. This one I'm going to have a common denominator of secant of x plus 1 and cosine of x plus 1. So let's see what we need. This guy has the plus 1, it needs the cosine. So this one's going to be cosine of x plus 1 over cosine of x plus 1. All right, let's take that and see this. Now this one's going to have to FOIL. It's not just a single term like that number 7 was. So I literally need to FOIL this whole thing out. So secant times cosine is a secant cosine. Secant times 1 is secant. Negative 1 times cosine is negative cosine. And negative 1 times positive 1 is a negative 1. Then I have a plus sign. And then I'm going to work on the second set. This one needs the secant of x. Oh, watch how you write that. Secant of x plus 1 over secant of x plus 1. All right, if I FOIL, cosine times secant is a cosine secant. Cosine times 1 is plus cosine. Negative 1 times secant is negative secant. And negative 1 times positive 1 is a negative 1. And all of this is still my numerator supposed to equal 0. Does anything cancel? And thankfully I do have some canceling things. Alright, so I have the secants are gone. Positive secant, negative secant. I have a positive cosine and a negative cosine. They're gone. But these are both negative 1s. And if I look at these guys, they both, I end up with 2 of them, right? I have a secant of x cosine of x and a cosine of x secant of x. They're the same thing, it's just they're opposite. They're inverted. They're kind of written backwards, but they're both the same terms. So what I really have is this. I have a 2 secant of x cosine of x minus 2 all over my denominator. Well, that's a little bit better to manage, right? Equals 0. And I know that secant and cosine are friends, right? They're reciprocals of one another. So what I really have, I'm going to play with my numerator a little bit. Secant is 2 times 1 over cosine times a cosine and then minus 2 all over my denominator. Alright, these guys cancel. This is a bottom cosine, this is a top cosine. And so what I'm left with, by the way it's supposed to equal 0, what I'm left with is 2 minus 2. Well, that gives me 0 over this crazy denominator of secant of x plus 1 cosine of x plus 1. And sure enough, 0 over any ugly denominator is still 0. So you have definitely verified that 0 equals 0. And that takes you to number 11. You see that one was a little bit more difficult, I think, than some of the others have been. And the last one I'm going to do is number 15. Here it comes. Number 15. Again, I don't see any identities that are screaming at me for anything, so I'm just going to try and do sines and cosines on with this one. So if I do that, let's see where that takes me. Cosine squared x on the left. Now I'm working on the right. Cosecant is 1 over the sine. And that's being divided by fraction a tangent, sine over cosine, plus a cotangent, cosine over sine. I'm going to leave the left. Cosine squared x is what I hope the right's going to come out to be. Let's see. This is the cosine over the sine. If I combine them together, I'm going to leave it as divided by. I'm trying to add these two fractions. Therefore, I need a common denominator. Between a cosine and a sine, I got to have one of each thing. Alright, then I got to match. This one has the cosine, it needs the sine. I'm multiplying him by sine over sine. Gives me a sine squared. This one has the sine, it needs a cosine. I'm going to multiply this one by cosine over cosine. That means I get a cosine squared. There's a plus sign in the middle. Happy dance. Sine squared plus cosine squared is 1. Alright, so this is going to equal 1. Let's do our keep change flip. Cosine squared x equals cosine of x over sine of x times, flip it, cosine of x, sine of x becomes my numerator. On the bottom, remember this became 1. And so here's where I'm at now. So sines cancel, bottom and top. Cosine times cosine is cosine squared, and I just verified that identity. All right, so hopefully those were enough examples to kind of get you thinking about where you're going to go for the rest of these. You will find all of our answers and videos on our Google Classroom page, but obviously email me if you've got any questions. Hang in there. These are challenging, but they're kind of fun. It's like a puzzle. You got to get to the end. It's like knowing the answer, but you just got to figure out how to get there. All right, I miss you guys, and I'll talk to you soon. Stay well. Bye.